Hello friends, welcome back. Today we are going to discuss a few concepts of fluid mechanics. First concept is the variation of pressure in horizontal direction, and the second one is variation of pressure in the vertical direction. We will discuss both these concepts first of all analytically, and then we will discuss both these concepts by experimentally. So it is verified to you and you can understand the core incentive of this concept. Okay, so we will start with the first concept, variation of pressure in horizontal direction. So we have considered here the element which is cylindrical. You can consider any element. It is a small element in the inside the fluid, or here you can see the container which have some points specified, respectively point A, B and C are on the same horizontal level, and point D is vertically below. It is some depth. It is at some depth. Okay, so we will first discuss. We have considered one element from this container, and we have shown all the forces acting on this element. Okay, so from the left hand side we can see that the force is pressure into area. So pressure into area, forces acting on the left hand side. On the right hand side we can see that we have assumed that by increasing the dx length, the pressure has increased from P to P plus dP, and the cross sectional area has remained same, that is constant, which is A. Okay, now for equilibrium condition, all these forces have to be balanced. Okay, so these forces we have to balance for the equilibrium condition. So we are balancing the forces. First of all we will balance, so we can write P into A minus P in plus dP into A, which is equal to 0. So we can see that there are only two forces acting, one from the left hand side, another from the right hand side. We are subtracting both the forces and equals to 0 for equilibrium condition. So we will get P into A, which is equal to P plus dP into A. We can see that A cancels out, P also cancels out. We get dP is equal to 0, which implies that change in pressure in the horizontal direction is 0. This we will also demonstrate experimentally. So we are going to first demonstrate first concept, and then we are going to discuss the second one. Okay, so we can see that this is a bottle which is filled with a fluid, that is water, and I have marked the points A, point B and point C on the same horizontal level. You can see that, and point D, E and F are on the vertical level. But first we will discuss on the same horizontal level, as we have discussed the variation of pressure in horizontal direction. Okay, so we have considered the horizontal points. So now you can see that I am going to remove this tape. Now we will open this tape and we can see how the pressure variation is going to take place. So I am removing this and you can see that first of all point A, we have to open the cap. You can see that water is flowing from point A. Now I am removing for point B. You can see that both the from both the points the range of this motion is same. We can see that as both these points are at the same horizontal level, so these both projectile motions are falling at the same distance from this bottle. Now I am going to open the point C. From point C and D also we get the same horizontal level. Okay, so now we are going to discuss the variation of pressure in vertical direction. Okay, so as we have seen in demonstration earlier, the variation of pressure in horizontal direction, we have justified the equation of pressure, that change in pressure equal to 0. Okay, so now change in pressure equal to 0, which means at same horizontal level, that is you can see points A, B and C are at same horizontal level, means change in pressure is 0, which means PA is equal to PB is equal to PC, which we have also seen practically by demonstrating with water filled container. Now we are going to discuss variation of pressure in vertical direction. Okay, so again I have considered one element which is cylindrical. You can consider any kind of element inside the fluid, as the element is very small, so you can consider any shape, arbitrary shape which you want. I have considered here cylindrical shape. Now we have to again balance the forces, because this element to remain in equilibrium, all the forces must be balanced. Okay, so we are going to balance the net vertical force. Net vertical force is equal to 0. So we can see that on the upper part, force is P into A, plus here in vertical element one force will add up, that is gravity, force due to gravity. Okay, so we will say that plus W, which is balanced by P plus dP into A. Okay, now we can write W is the weight. We can write mg, PA plus mg, which is equal to P plus dP into A. Now mass is defined as density into volume, and volume is defined as area into length. So we have considered the elemental length is dy, so we will multiply A into dy. A into dy, you will get dV, and mass is equal to density of water into dV. This is small mass, dm. I have to write small mass here, that is dm. Okay, so now we are going to solve this equation. Pa plus what is the value of dm here? It is rho into dv. We can write rho into dv. Again we substitute the value of dv. We substitute the value of dv as a into dy. So we will write a into dy, which is equal to p plus dp into a. So we can say that a gets cancelled out from all the sides. A is cancelling out. So p is also cancelled out. So we get dp upon dy. Sorry, I have forgotten the g here. You have to also include g, which is from the above equation. So we will get dp upon dy, which is equal to rho g, or you can say that dp is equal to rho g dy. So our basic aim here to see that the change in pressure depends on density, acceleration due to gravity, and height. Height of the element is dy. So change in pressure depends on the three factors. First is density. If you change the density of the fluid, so suppose I have considered here water. If you consider mercury or any oil, so suppose you have considered oil, which is a density of 850 kg per meter cube. So its pressure will be obviously less, because its density is less than water. Density of water is what? Density of water is 1000 kg per meter cube. Okay, so now we are going to demonstrate this variation of pressure in vertical direction. So we are going back to our same container, which is filled with water, and we will demonstrate the different variations of pressure. So welcome back. We can see that A, B and C are at the same horizontal level. So as we have discussed the earlier concept, you can revise. A, B and C are at same horizontal level means all the 3 points have the same pressure. This we can see that. I'm opening the cap. You can see that all the 3 points have same pressure. You can see by demonstration. All the 3 points have same pressure. देखो सब जगह से same horizontal level पे पानी गिर रहा है. Okay. So now we are going for vertical. Now we are going for vertical points, that is D, E and F. Now I am going to remove this tape, and you can see that D point water will go somewhat nearer, E point water will go far away, and F point water will go more far away. Okay, because of the point variation, we can see that pressure increases with height. Now I am going to remove this. See, F point, the water is going far away than E point. So from this demonstration, it is clear that pressure varies with depth.